Hello again, students. I'm pretty excited. It's day 10. Double digits. Day 10. We're getting close. There's only 13 days in this unit. Test is coming. Oh, I know. It's kind of scary. The test is coming. It's right around the corner. All right, let's see what we got here. Where's Mr. Key? Where's Mr. Key? Here's Mr. Key. Why is Mr. Key in blue? That's really weird. Mr. Key. Mr. Key. Okay. So, the absolute value of x is greater than 5. So, let's take a look. Maybe I can blow this up a little bit. Let me see if I can blow this up a little bit. View. Let's see if I can go like 200%. And let's see. Can move that over. Oh, I know what I can do. Slide it over. All right, here we go. So, I'm going to look at these two functions right here. So what I've graphed in blue is the absolute value of x. Straight up parent function of the absolute value of x. Oh, by the way, if you need the notes for this, go to mrkrausemath.com. Krause, that's MRKRAUSE, math.com, all one word. Then go to like set 2 or set 3, and then whatever, and then you look for Unit 1, Day 10. You can get the note, you can get the homework assignment, click to the video, you can click all the other videos. If you love what you see, I'm not talking about this ugly mug with the shiny head, but I'm helping you out. Hit the subscribe button. You like more subscribers, better for me. And if you really like it, or if I saved your kahuni or tail, hit that donate button. It's going to pop up somewhere over there, somewhere up in the left-hand corner. That would be cool because I'm going to need a new computer before this year's over. And I got a kid in college. He's costing me an arm and a leg. He's at RPI. Hi, son. Yeah, chance of him watching this is 0. Let's get going. Back to work. So this is the absolute value function. That's what I've graphed in blue. And in red, I've graphed the line y equals 5. Well, it should come as no surprise, especially after yesterday's lesson, that they intersect at these 2 points. So those are the 2 points of solution. So if I wanted to answer it, of course the answers are positive 5 and negative 5. Hopefully that's 5. I don't know, it's over there somewhere. Negative 5. 1, 2, 3, 4, 5. Yeah, negative 5 and positive 5. So those are the 2 answers to my solution. So this question here is saying, when is the absolute value greater than? We talked about that the other day. Greater than means we're talking about the y values. When is it above? Raise the roof. Raise the roof. Gosh, I'm like a rapper. Yeah, whatever. So when is it above? So if I take out my handy dandy highlighter and I look, wouldn't it be above here? And wouldn't it be above here? Well, sure then. And so if you were to take this and throw it on a number line, you would say, wait a second, if I had the number line, and yeah, that's a line. Stop messing with me. It's a straight line. It's perfectly straight. And I had a number out here at negative 5, and I had a number out here at positive 5. That's where they were equal to. That gives me the cutoff points. That's where they change from one being equal less than, one being more than. And we said, right up here, we agreed, wherever my mouse pointer happens to be, we agreed, way off, that over in this area, it was bigger than, or above. Over here, it was bigger than. So, not including the 5, but going off in that direction, it would be bigger. And not including negative 5, and not including the positive 5, we can go off in that direction. This is where, up in this area here, and here is where it is greater than. So then where is it less than? Well, it should come as no surprise that the blue, or the absolute value, is less than that point down here. And if I was graphing that on a number line, ooh, much straighter line. That's actually kind of almost perfect. Almost perfect. Negative 5 to positive 5. Again, I'm using open circles because there's no equal. Oh, wait a second. I just realized that it had an equal to. See, we did equal to yesterday. It has an equal to, so I actually have to include that. I have to include that because in this case it's equal to. And then I come over here and it's also equal to, so I'm thinking, oh, wait a second, we got to include that point. And 5, and we'll include that point. But in this case, the only place it's going to work is in between. And so when I do in between, I'm going to connect the dots. So if I wanted to write that in, let me get out of this view mode. Let me try. That's not bad, though. Let's try 175. That's 176, I think. 175? That's not bad. We'll do that. If I want to try this, interval notation, well, in interval notation, this is negative infinity all the way up to negative 5. And because, yes, it does have the equal to, we put the bracket, union at 5 to positive infinity. What would this one look like? Well, this one's actually much simpler. It's bracket negative 5, comma 5, bracket. So from negative 5 to 5. This is the inclusive. This is the connected dots one. This is the outside or the going off in either direction one. All right, and if I did an inequalities, it's actually kind of easy. X is less than or equal to negative 5, or X is greater than or equal to 5. Remember, this is like the original. This is like the negation. Notice I flipped the sign. That's going to become important. What I mean by that is if you go back to the original, right? And I go back to the original. I wrote the original down here, and I wrote the negation of 5, but I also flipped the sign down here when I wrote it in inequality notation. You see that? So here's the original. And then here's me writing the negation of this side, but I also flipped the sign. We're going to talk about that. And in inequality notation here, no, in interval notation here, in inequality notation here, it's negative 5 less than or equal to X less than or equal to 5. All right, that's it, kids. Why did I put those stars there? Well, I forgot. Doesn't matter. Moving on. You'll never have an equation that looks like this. Yeah, you'll never have one like, I just want to make sure you understand it. You're never going to have something that looks like this. Right? Never, ever, ever will you have things pointing like that in two directions. It just doesn't work that way. So to solve absolute value functions, we are going to isolate weird thing. Weird is one of those words I don't know if I spell correctly. Ever. Weird thing. Then we're going to split it into two equations, two inequalities. But we got to remember to, I didn't put it here, flip the inequality. Some sick writing right there. Sign. Sorry, bros and sisters, my sisters and brothers. Brothers and sisters. All right, so here's what I've done. Here's what we've done. We've done this. We've graphed the equation 3 minus, the absolute value of 3 minus 2x. That's this, in the blue. We've also graphed the line y equals 4. And I want to know when it's less than. Well, less than's down in this area right here. So it's between whatever this is, and inclusive, and this here. So I know that I'm not going off in either direction. I know I'm going to end up connecting the dots. Now, graphically, that's great. So now we're going to do it algebraically. Ching. Write the original. It's just like yesterday, except for the pen's not working. There we go. Back. 3 minus 2x less than or equal to 4. This is the original. Now this is where the big change happens. You're going to do everything pretty much the same as yesterday, negate the right side, but this sign has to flip. Flip, 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 flip. Flip it. Or I'm going to flip you. Flip it. Right? It's kind of like dividing by a negative. Aren't we negating the right side? And don't when we divide by a negative or multiply both sides by a negative, don't we have to flip that sign? It's the same idea, same principle. We have to get the two zones where it's going to be equal to. All right. Now let's solve these. We're going to subtract 3 from both sides. So I get negative 2x is less than or equal to 1. And then I'm going to divide by negative 2. Ooh, wait a second. Here we go. We just talked about this 2 seconds ago. We're going to divide by negative 2. What do I have to remember to do? That's right. Flip the sign. Negative 1/2. And over here, we're going to solve. So negative 2x is greater than or equal to negative 7. Divide by negative 2. Again, I'm dividing by a negative, so I got to switch the sign again. X is less than or equal to 7 over 2. And this looks like about a half. That looks like about a half with that hit. And here's 3.5. And that's what this is. So again, it's in the middle. So I've got to write it either in inequality notation or interval notation. So I'm going to do both. So negative 1/2 is less than x, or equal to x, is less than or equal to 7/2. Because the x is in the middle, you got to write it like this, and these will always be less thans here. Whenever you're going to write it like this in equality notations, and you're connecting the dots like this, or the x is in the middle, those have to be less thans. Why? Because it's less than this one, but it's greater than this one, and that's why you do it that way. Interval notation is much easier. You don't even have to think about that. Since it's got an equal sign, we'll put the bracket, negative 1/2, comma, 7/2, bracket. Done. So this one says we want to be greater than 1. So greater than 1 means I want to be in this one. So this means we got the or case. We're going to be something this way or this way. So that's what we're going to have to do. First things first, split it up. 4x minus 5 over 3 greater than 1. Now comes the crazy part. Flip it, flip it. Got to do a little flip it, flip it. I might do a flip in class. I'm just going to flip right over. Somebody call the ambulance before I start it, though, because I'm certain I'm going to get crushed. 5x over 3 over 3. So now everything gets flipped. We're going to flip that sign, and we're going to negate it, right? It's like dividing by a negative. Whew. When I divide by a negative, I have to drink my Burger's coffee, which is cold by now, and I spilled half of it on myself last video. And almost cursed. If I had cursed, I would have figured out a way to bleep it out, but I didn't. I saved it. So let's solve these. So I'm going to multiply this side by 3, and I'm going to multiply this side by 3. Don't do cross-multiplying crap, because you're getting all kinds of problems. We're just going to multiply this side by 3, because those 3's will cancel. So I end up with 4x minus 5 greater than 3. You do that cross-multiplying stuff on inequality, you don't even know what side to put things. You put things on the wrong side, you get them on the wrong side, they don't even know what's going on. So don't do it. Add the 5, I get 4x greater than 8. X is greater than 2. Let's see, does that make sense? Oh, look at that. 2. Do you see how using your graphing calculator can help? We're going to show you that. We're going to do that a little bit. Maybe later. Do the same thing. We're going to multiply by 3. Now, again, we're multiplying by a positive 3, so we're not changing any signs. We're just going to multiply by 3, and we get 4x minus 5 less than negative 3. We're going to add 5, so we get 4x is less than positive 2. And then divide by 4, and I get x is less than 1/2. And does this point look like it's at about a half? Look at that. It looks like it's right about a half. Now, we said less than a half. That would be this direction, and that would give us this piece. We said greater than 2. That's this direction, and that would give us this piece. So my answer, because it's in opposite directions, is x is greater than 2 or x is less than 1/2. And it doesn't matter that those are on the wrong side. If you don't like it because this goes with this and this goes with this, I don't like it that way either. I might write it x is less than 1/2 or x is greater than 2, only because this piece goes with this side and this piece goes with this side. Doesn't matter. Either way, it's fine. Let's do it in interval notation because that sounds like fun. Yeah. Interval notation. So let's see. X is less than 1/2. That would be all the way from negative 1 infinity up to 1/2, but not including, because there's no equal sign, so we put a parenthesis. Union, because that's the or. 2, no parenthesis, to 1 infinity. Great. Lovely. I got to switch colors because I'm bored. And colors make me happy. I'm just kidding. So we got to get the weird thing alone. Wish I was comfortable with one of my students, because I'll call one of my students the weird thing this year. So we got to get the weird thing alone. It's all for fun. So I got to get this absolute value thing all by itself. Let me highlight that in a color, like a highlighter color. This thing's got to be all by itself. So everything else with it's got to go. Got to go, we don't like you. Now, just like with solving equations, we take care of the adding and subtracting first. So we're going to move this over first. You don't start splitting this thing up until the weird thing is alone. So you get -3, absolute value of weird thing, is less than -15, because we're going to subtract 4 from both sides. Now I'm going to divide by a negative. Whoa, 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 Dolly. Dividing by a negative, Mr. Krause. Doesn't that mean? Yeah, it does. You got to flip the sign. So we're going to do that right now. You got to follow all the rules you've learned. Why do you think we teach you those rules? Because we expound on them, expand on them. Whatever I'm thinking. Greater than 5. 2 negatives when you divide them is a positive, and since we divided by a negative, the sign has to flip. The weird thing is now alone. We're in great shape. Let me draw a different color. Let me go into black. Black's cool. Go black. Now we're going to split them up. 6 minus x is greater than 5, the original. And the flip it. Flip it. You're going to get flipped if you don't flip it. Flip the sign, -5. All right, we're almost done. Oh, by the way, take a look. We never looked at the graph. I want where it's less than -11. Well, here's where it's equal to -11. And I want when the absolute value thing is less than. Well, wouldn't less than mean below? So I'm looking at an OR situation down in this area. So I should come up with an OR situation. Let's check it out. Let's check it out. So let's see. Bring the 6 over. I get -x is greater than -1. Or dividing by a -1, I get x is less than +1. Let's see if that makes sense. +1, there it is, and x less than that. Okay. Now we're going to bring this 6 over. We get -x is less than -11. Divide by -1, I get x is greater than 11. Now, let's see if that makes sense. Is that about 11? I think it is. So again, if you did not graph it like this and you didn't see it like this, what you would have to do then is come up with like a number line and say, okay, here's 1, here's 11. Okay, it's that way and that way. Did I actually tell you to solve and graph this? Oh, show the solution on a number line. I forgot to do that. Bad me. I'll come back to that in a second. Let's finish this. Oh, this would be this one on a number line. So it's going off in either direction. And I'm going to be doing this in class. I just totally blanked on that. Sorry. So my answers are, well, there's one of my answers, that. Or I can do it in interval. That is inequality notation. Or I can do it in an interval notation. -infinity up to 1, not including, or 11, not including, comma, infinity. And I apologize for not doing these. You know, it's very difficult to see. Like this, if I was to draw this one on a number line, if you don't use your graphing calculator, how are you going to know if it's an or an and if you don't put it on a number line? Here's a 1/2, and we said less than, so that would be open circle, less than. And here's 2, and this says greater than. That goes off. And whenever you go off in either direction, that's an or. That's an or. Over here, I believe this was the and, right? This was the and. So if I was to graph this one on a number line, and I would say, okay, here's -1/2, and here's +7/2. It's over here somewhere, closed circles. And we said, hey, we're going bigger than that and less than that. Oh, connect the dots. Connect the dots. All right, let's take a look, see what we got here. Which inequality is represented by the accompanying graph? You know, and it's really easy to try to guess. You know, I don't know. So what I want to do is teach you to work backwards. Let's try 0. And let's see if 0 works. If 0 doesn't work, well, actually, let's try 10. So if we try 10 and it works, that might be the one or that might not be the one. So 10 minus 2 is 8. 8 is greater than 7. That works. 2 minus 10 is -8. Absolute value of -8 well, less than negative 7. An absolute value can never be negative, so it can't be less than negative 7, so that one doesn't even make any sense. And this says greater than negative 7, but yeah, that's always going to be true. But that's probably not true either. So let's go 10 minus 8 is, so absolute value of 10 minus 2 less than 7. This is 8 is less than 7. That doesn't work. Now this gives me 2 minus 10 is greater than negative 7. This is 8 is greater than negative 7. Well, that's true. So one of these two has to be right. One of them. So let's try another number. Let's try negative 10. Negative 10 minus 2 is negative 14. Negative 12. Negative 12, the absolute value of negative 12 is in fact greater than negative 7. So let's try negative 10 down here. Let's say negative 12 down here. These are always going to work. I don't know why that seems to be working. Let's try it. Let's do this. I think the answer is A. Didn't I get my eraser? I think the answer is A. Let's do this. I know it's not those two. Those two don't make any sense. And I'm relatively certain it's not these two. But let's do this. Let's just do it. This is x minus 2 is greater than 7, or x minus 2 is less than negative 7. This gives me x is greater than 9. Hey, it looks like this. And this gives me x adding 2 is less than negative 5. And there's negative 5 going that way. So this is your right answer. If you were to do this one, you would get 2 minus x is greater than negative 7. Or 2 minus x is less than 7. Now if I solve this, subtracting 2, I would have negative x is greater than negative 9, or x is greater than 9. Solve this, I get 2 2, so that's 5. So negative x is less than positive 5. And then I get divide by negative 1, divide by negative 1. This is where this is going to be a problem. X is greater than negative 5. And x is not greater than 5. It's less than 5. So that one doesn't work. That was a kind of an obnoxious question. So let's see what we got here. First of all, you're almost always going to get two solutions. So it's either going to be a compound one or it's going to be an inequality one. I just don't know which. So if I solve these, I get x minus 2 is less than 3, or x minus 2 is greater than negative 3. And that's what needs to be solved. Well, this one gives me x is less than 5. And this one gives me x is, oops, I forgot to switch the sign. Oh no, I switched it. X is less than 5, or x is greater than, I apologize, negative 1. So those are what I got. I don't know which one it is until I grab the number line. Here's negative 1, and here's 5. It's got to be less than 5, or it's got to be greater than 1. So this is the connected dots. Anytime it's a connected dots, this is your answer. All right, more examples. Now I'm not going to get through all these in class, so if you would like, you can do them all on your own. When you use algebra, we're going to graph them, and then we're going to graph it on the number line. So we're going to write our answer and then graph it on the number line. So 4 minus 2x is less than or equal to 8. Or 4 minus 2x is greater than or equal to negative 8. Let's solve them. Negative 2x is less than or equal to 4. Divide by negative 2, and I get x is greater than, we're dividing by negative. Notice I'm flipping the sign, greater than or equal to negative 2. So there's one part. I flipped it and I negated. So negative 2x is greater than or equal to negative 12. divide by negative 2, divide by negative 2, and I get x is less than or equal to positive 6. Now, I don't know if this is an and situation or an or situation. So here's negative 2, it says greater than or equal to, going that way. Here's 6, less than or equal to, connect the dots. So my final answer would be negative 2 less than or equal to x less than or equal to 6, because it's a connect the dots situation, not a arrows going off in either direction. All right, let's write the original. 2y over 3 plus 2 greater than 2. And we're going to write the flip it. 2y over 3 plus 2 is less than negative 2. Now, in order to solve this, again, don't forget, we're going to multiply through by 3 because we have to get rid of that fraction situation. So these cancel. 26 minutes. These cancel. And then so I get 2y plus 6 greater than 6. Move 6 to the other side. I get 2y greater than zippo. Divide by 2. I get y is greater than 0. So that's part of my solution. And over here, I'm going to these cancel. So I get 2y plus 6 is less than negative 6. So I get 2y is less than negative 12, or y is less than negative 6. So greater than 0 and less than negative 6. If I have to look at that on the quick number line, I don't know if it's an and or an or situation. Can I just write an or in the middle here? Or do I have to rewrite it as a compound inequality? So let's see. Here's negative 6. Open circle going that way. And here's 0. Open circle going this way. So this is an or situation, so I can just write or in here and I'm done. Just say you want me to write an interval notation? Oh, write your answers in interval notation. So in this case, I can't leave this. It would be negative 2, comma, 6. And over here, since it's an or situation, I have to write negative infinity up to and include, not including negative 6, union 0, comma, positive infinity. All right, I got 6 more to do. Like I said, we're not going to get through these all in class. I'm only doing these as extra examples for you if you need them. So let's go. Wait, I thought I did this one already. X plus 2 is greater than 5. Guess not, kids. That's what happens when you do math over and over and over and over again. You think that you've done them. I have done these problems, probably in the past. So we're going to write as the original. I'm going to go through quite quickly. X plus 2 is greater than 5. Or my other one is going to be x plus 2 is less than negative 5. Split them up. This gives me x is greater than 3. This gives me x is less than negative 7. Put them on a number line. Here's negative 7, less than. Here's 3, greater than. This is an or situation. So this would be the inequality answer. This would be the graphic answer. And then in interval notation, you would, of course, write negative infinity up to 3, union. Whoa, 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 whoa. Let's back up the crazy train there, bro. Let's pretend like that doesn't happen. Let's try this again. Negative infinity all the way up to negative 7, not including either, union 3, all the way to positive infinity. Much better. All right, let's do this. And you can't generalize if it's less than it's going to be this, if it's more than it's going to be this. You don't know. You just don't know until you've actually done the problem. So we're going to rewrite the original. 3x minus 2 over 4 is less than or equal to 5. And to flip it, whew, don't F fraction, because we're doing fractions. Don't F fraction with the left side. Only mess with the right side and the inequality sign in this case. So greater than or equal to negative 5. All right, I'm going to grab a different pen. I'm going to multiply both sides by 4, because that means I can get rid of this. And I get 3x minus 2 is less than or equal to 20. And then I'm going to move the 2 over. I get 3x is less than or equal to 22, or x is less than or equal to 22 over 3. How could that possibly be right? Multiply both sides. It is. Multiply both sides by 4. Multiply both sides by 4. I get 3x minus 2 is greater than or equal to negative 20. Add 2 to both sides. I get 3x is greater than or equal to negative 18. Divide by 3. I get x is greater than or equal to negative 6. Now, I don't know if I'm going to put an and or an or in here. I just don't know until after I've taken the time to graph these things. So let's see. Here's negative 6. Close circle. And we're going to the right. Right now I'm thinking we're going to be connecting the dots. 22 over 3, that's really close to 7. But it's over here. And we're going less than or equal to. Boom, this way. And we'll connect the dots. So if it's a connect the dots situation, then we have to do it in interval notation. Let me do this in green. Bracket. Let's see, the small number goes on the left, so that's negative 6. And the large number goes on the right, 22 over 3. There she is. Moving on. Split them. Again, pause this. Try it on your own. See if you get the right answer. 2x plus 4 is greater than or equal to 12. Let's change the right side. Don't mess with the left side. I can say mess this time. Don't mess with the left side. Less than or equal to negative 12. I don't know. And or. Won't know until I've graphed it. 2x is greater than or equal to 8. X is greater than or equal to 4. 2x is less than or equal to negative 16. X is less than or equal to negative 8. All right. Throw these puppies on a number line. Oh, yeah, that's a number line. You'll do a much better job. It's very difficult to do it when I don't have flat paper or I don't have lines. I should put lines on this. Maybe that'll help. That might maybe help. Or maybe a piece of graph paper. Here's negative 8. Closed circle going to the left. Looks like it's already going to be an or situation. Here's 4. Closed circle going to the right. That means it's going to be or. So this is interval. This first one is inequality notation. This is graphically, and now we're going to do interval notation. Negative infinity up to and including negative 8 union including 4 all the way up to positive infinity. Uh-oh, got to get the weird thing alone. So we're going to multiply both sides by 2. Multiply both sides by 2. These 2's cancel. And I can distribute the 1, but really what I'm just left with is 4 minus 2y. I don't need that 1 out front. Is greater than 8. Got the weird thing alone. That's the best way to get rid of fractions. We don't like fractions anyway. Just get rid of them. Now let me grab a different color because, color makes me happy. You know me. I'm never happy. So let's just split these up. Original, flip it. So, this one's going to get funky. Funky Co Medina. 4 minus 2y is greater than 8, or 4 minus 2y is less than negative 8. We're going to flip them. Flip them. Oh, yeah. Now we got to solve. Subtract 4 from both sides. I get negative 2y is greater than 8. And someone's saying to me, why don't you show your work there, Mr. Grouse? Because you're in algebra dos, zwei, due. Means you're ready for a little bit of extra work. You're a little bit for mental math. Ooh, that kind of hurt. We're going to divide by negative 2. Now, now I'm showing it here only because we're dividing by negative 2, and so we got to remember to flip the sign when you divide by negative. Move the 4 over, you get negative 2y is less than negative 12. Divide by negative 2, and you're going to flip the sign again. Y is greater than positive 6. So I don't know what this thing looks like on the number line, but that number line, as long as you tilt your head, that number line's gorgeous. Here's negative 2. We're going less than. Here's 6. We're going greater than. That means it's an or situation. In interval notation, it would be negative infinity up to negative 2. not including -2, union 6, not including 6, all the way up to positive infinity. We're almost done, chillin'. So what do we got here? What is this crap? So 3x minus 12 over -4 is less than 3. Or, I don't know if it's or. 3x minus 12 over -4 is greater than -3. We're going to multiply both sides by -4. Wait a second, I'm multiplying by a negative? Does that mean I have to flip the sign, Mr. Krause? Because I don't even remember. Yes, it means you have to flip the sign. These go. So I'm left with 3x minus 12 is greater than -12. Multiply by -4 here. Multiply by -4 here. Ka-ching, see ya. So I get 3x minus 12 is less than 12. All right, now all I've got to do is solve it. Add 12 to both sides, I get 3x is greater than, 0. Divide both sides by 3, I get x is greater than 0. That's not a problem. Over here, I'm going to bring this 12 over, so I get 3x is less than 24, or x is less than 8. Let's look at it on the number line just to see what we got here. 0, 8. Greater than 0, less than 8. So this is an and situation, so you're not able to just leave it like this. You can't write the word and in here. So what we want to do is we want to write this as a compound inequality. We want to put x in the middle. So we're going to do 0 less than x less than 8. X is in the middle. Or parentheses 0, 8, parentheses. There it is. All right, last problem of this day. All right, so what we're going to do is we're going to divide by -3. Still got to get the weird thing alone. We're dividing by a negative, so you have to flip the sign. So I get the absolute value of 2 plus z is greater than or equal to positive 2/3. All right, now we're going to split them. So I get 2 plus z greater than or equal to 2/3. 2 plus z less than or equal to -2/3. Now I don't like having that fraction there. It bothers me. I know it bothers you, so we're going to get rid of it right now. You know, you have to do this? No, if you're comfortable in other ways, go do it another way. So I'm going to multiply through everything through by 3. So I get 6 plus 3z greater than or equal to, 2. Let me finish this. 3z is greater than or equal to -4. Divide by 3, I get z is greater than or equal to -4/3. That's part of my answer. Is it going to be an or is it going to be an and? I don't know. 6 plus 3z less than or equal to, these go, -2. We'll subtract 6, so I get 3z is less than or equal to -8. Divide by 3, and I get, I don't know why I have -4 here. These should be positive. And this should be positive. And I get z is less than or equal to -8/3. And when I draw this on the number line, -8/3 is close to -3. So there's -8/3 less than or equal to, going off in that direction. And 4/3 should be somewhere over here on the positive side. 4/3. That's a 3. My computer's going crazy. And going to the right. Interval notation. Let's see if I can get through this on a pen. Negative infinity. My pen is going. Negative infinity all the way up to -2/3 with a bracket. And then starting at -8/3, we're going with a bracket all the way to, no, starting at 4/3. Bracket all the way up to positive infinity. My pen's dying on me. I don't know why. That's it, kids. There she goes. That was a lot of extra problems for you, just in case you're struggling with that things. The key is get the weird thing alone, split it up into 2 equations. The original and the negation. You flip the sign and you negate the right side. It's been fun working with you today, guys. Alrighty, have a great and glorious day.